The umbrella for dependent versus independent events is called conditional probability, meaning there are conditions, especially when it's dependent, there's conditions, right? Something happens first and it affects the second event, okay? So that's the umbrella term. Company screens, job applicants for illegal drug use during their hiring process. The specific test they use gives a false positive 2% of the time. Okay, so it says that you have drugs in your system, but it's actually not true, right? And a false negative 1% of the time. So it also does it the other way, right? Like technically you have drugs in your system, but it could be wrong 1% of the time. Okay. Suppose that 5% of all applicants actually use illegal drugs. What's the probability that someone will test positive? Now, I'm hoping that you will realize, wait a minute, usually I will tell you, do a tree diagram. The province will usually tell you. But even right now, we're in this section anyway. So what happens first? What needs to happen first before the test can be either false positive or negative? You need to actually have drugs in your system, right? So we've got, I don't know what letters I used, but let's say you consume drugs and the option is, the other option is not consuming drugs. Oh, you can't see that. This screen is flickering. I don't know what's wrong with it. That's why I'm off, sorry. So drugs and then not drugs, right? So there's a 5% chance, so I'm going to go decimal here, 5% chance that or 5% of the applicants actually use drugs. Therefore, 0.95 or 95% are not going to be using, the ones that are applying for it. And then for each case, you will either test positive or negative, which is P naught, right? You'll test positive or negative. So positive or not positive. You can say positive, negative if you'd like to use that terminology, like rainy, sunny, rainy instead of sunny, not sunny. It's okay. But I think the not helps you realize, okay, these need to add up to 100%, right? So when you use drugs, okay, there could be a false negative of 1%. Okay, technically, right, if you go down this branch, there are drugs in your system, and it will say no, that you don't have 1% of the time, which means that 99% of the time it will actually say, hey, you have drugs in your system, and rightly so. It's a true positive, okay? This is that's how it's the wording that throws you off maybe a little bit. On the other side, if you go down this branch, these are all the applicants that do not have drugs in their system, don't have anything. They'll get falsely accused 2% of the time. It's a false positive. Sorry. Yeah, it goes this branch. It'll be positive 2% of the time. We call it a false positive because we know you don't have any. I just had to think about the wording there. So that means that 98% of the time, and rightly so, it'll say no drugs in the system. So that's how you set this up, okay? And what I would suggest you do, just multiply these two, right? You'd say that probability of having consumed drugs and actually testing positive is when you multiply these two, that is 0.0495. Probability of consuming drugs and actually being told, no, you don't have drugs in your system, 0.0005. It's a very small chance that happens, okay? But it does. If you're talking thousands and maybe millions of people, it actually comes into, right, there's a significant amount of people that will be blamed for using drugs, even though or in this case, there's a lot of people that will get a negative even though they did consume drugs, right, in this case. probability of not using drugs and being accused of consuming, you multiply these two, you get 0.019. And then probability of not having used drugs and also getting a test that says you don't have any in your system is 0.931, which is what we want, right? I just did a check. This adds up to 1. So if the branches add up to 1, you're in pretty good shape. I'm not guaranteeing you 100% on that, but that is a good indicator you're doing things right. Okay. So when you branch off, make sure that the it happening, it not happening adds up to 1 in and of itself, right? Every kind of branching off, that should be 1. This should be 1. And then at the very end, when you multiply everything, you have that. So A, what's the probability that someone will test positive? You add up this one and this one. Okay? So you add up 0.0495 and 0.019. That adds up to 0.0685. You can leave it like that if you want, or you can say or 6.85%. Either one is fine. Okay. That's this question here for you. I want to use the previous example, like we started one yesterday and I didn't do the other ones like C and D. I want to talk about them today. Okay. Copy this down. Don't mix things up. So for example, drugs and then positive. You're mixing up, like you're putting stuff that is supposed to come second in here and you're mixing them up. Don't do that. So kind of focus on, for example, if I have my 5% here, 5% of applicants use illegal drugs, then you should realize, okay, so then drugs, not drugs, 5%, 95%. Like don't mix up the columns, right? That's what I'm trying to say here. So let's go to 43. Because I never finished that one. And I think before I do 43, C and D, I'm going to go back even more, okay? I'm going to go take you to 41. 41. And I want you to add this formula to your formula sheet. When are you going to use this formula? Well, obviously, do you remember what this meant, the little vertical line? What does that, are we talking dependent or independent when this is the notation? Dependent, right? Dependent. So when you notice that that's the case, and we are in it, when you do these tree diagrams, I mean, come on, like the first thing affects the second one. We can tell. What I want you to say that this is probability. I don't know if you want to do it in this box or outside around it. Probability of B given that A happened. This is the one formula that I want you to make sure you include as well as a bunch of other ones that I've already given you, but this is the one. You can say dependent events. Now, I have to tell you this. Will the province always say use the word given? Not necessarily. They've done, hey, find the probability of B happening knowing that A happened, right? So they won't always use the word given, but you know that when you are in a scenario, as I'm about to show you here, let's go back to 43 now. If you have this scenario, you're on 43, what is the probability of having placed a sign given that someone fell? Okay, you should recognize that word given. And let's try to write out the formula for this one. Probability, if we use the letters that we have right now, we know this is going to be a given. We know it's going to be something like this. The probability of having placed the sign, so let's go S, knowing that someone fell. That's what the question is asking. Okay? That's what the question is asking. So I want you to, when you come across this, think, oh, that formula Mr. Dirksen gave me with the bar, that's the one we're supposed to use here. Okay? So let's go to C. And I'm going to do that right down here. It's asking for, one more time, probability that the sign was put up given that someone fell. So someone's asking, maybe you, I hope this doesn't happen to you, but let's say you fall and you go to the office and you're like, I fell and I hurt myself. We're asking, okay, knowing that you fell, what are the chances that the sign was actually up? That's what we're trying to ask here. We're trying to go backwards, okay? So how will this formula go if we go by the one I just gave you on 41? Let's go back to 41 and let's assume this is on our study sheet. If it's BA, right, then we use those two letters and say, at the very top, we need the probability of both of them happening. And at the bottom is the probability of A, which is which letter here in this mix? It's that second letter. Okay, so that's the pattern. So let's go ahead and use that. So basically, this is probability of sign and F. Mr. Dirksen, does it matter if I go F and sign or sign and F? It doesn't matter. This thing keeps on turning off on me, sorry. Thank you. It's probability of sign and F. So it doesn't matter which order you put them in, as long as you say, I'm going to figure out the probability of both of them happening up top. That's the number that goes up top. In the denominator, it's probability of which one? Which one of these two has to come down here? This one, the F. This is rare on an exam, I'll tell you that. But it has happened, so I'm going to prepare you for it. So let's go ahead and just find this number. Do we know sign and F, the probability of these two things happening? Let's go up here. Way up here, way up here. Probability of sign and F. So you would scan your outcomes and you look at this one and it's 0.1826. So 0.1826 divided by. Do we know the probability of someone falling? Mr. Dirksen, yes, we calculated that yesterday. We already did that, correct? We know the probability of falling is 0.2846. If you hadn't done this already, you would have had to go and add up all the instances where someone is falling, which is 2 branches on our tree up there, right? Now you divide that, and you get, where are we here? 0.6416. Or 64.16%. The province won't care which one you give. in this one. Like it'll just say, as long as you calculate it and you give either one of these, you're fine. However, if the denominator is smaller than the numerator, you're going to get a wrong answer. You're going to get something that's over 100%. So you got to make sure. What students often forget is like falling. They just go up. Oh, falling is right here. It's this one. Or is it just this one? Which one is it? So they just do bingo and they just take one of these and put them down in the denominator. You want to make sure you add up both of them. So I'm going to highlight the fact that I've already done the work before, so I could just conveniently use that in my calculations and just figure it out that way. D. Let's read it. What is it asking? What is the probability of not having placed the sign given that someone fell? So let's read this. Probability of the custodians forgetting to put up the sign given that someone fell. That's what it's asking for. So you need to kind of translate that within the question. All right, let's go to the bottom of this page. You can see it, right? Yeah. So translate that one more time. This is what the question is asking. So what's the pattern? These two happening at the same time goes up here. And what goes down? Probability F. Yeah. Try to figure that out. Plug in the numbers and see if you get that. You need to go find it. U time. So not putting the sign and falling, I have that up here on my diagram. It's 0.102. Probably a falling, I already know what that is conveniently. And if you divide those two, you get 0.3584. Okay. 0.3584 or 35.84%. All right? Any more questions? Okay. I'm just going to say this. For the test or exam, I mean, I'm guaranteeing you that you're going to get one of those on the test, like the given that. And I'll be nice and I'll try to make it very obvious. And I will also have a scenario where you need to make a tree diagram, and I will prompt you to do that. I'll say use a visual or a tree diagram. Use a tree diagram. There's other ways of doing this, but tree diagrams are the best way to do this. And then solve. By the way, what are tree diagrams for? Okay, tree diagrams are for you to see all possible scenarios. Up until this point, I may have asked you to just figure out what's the probability of putting the sign up and falling? And you would have just done this times this, and then you get your answer, right? This tree diagram shows you everything. Putting up the sign, not putting up the sign, and then falling versus falling, falling versus not falling. Okay, not falling, I meant to say here. Falling versus not falling. So you're looking at every possible scenario, including where the sign has not been put up and nobody fell. Okay, so you're including all possible cases. That's what a tree diagram is good for. I'm going to stop here.